Welcome everyone. I've just hit admit, so we'll just let everyone filter in. My name's Nicole Lloyd. I am the Senior Communications Officer at Beyond Zero Emissions. I'd like to welcome you to our June discussion group. We are looking at the Hunter again, part 2 of our series, and manufacturing for a zero emissions economy is our topic. So we'll just give it a minute, checking that most people are able to join. Okay. All right, and I will introduce our guests in a moment. We'll hand over to Sam actually, who's going to introduce our guests. But first, let's just, we'll do an acknowledgement. So I'll start by acknowledging the Bunurong people of the Kulin Nations. They're the traditional custodians of the land on which I live and work, down on the Mornington Peninsula. I pay my respects to their elders, past and present, and acknowledge that sovereignty has never been ceded. And I'd also like to extend that respect to any Aboriginal or Torres Strait Islanders joining us today. And as we always do, if you'd like to acknowledge the country you're joining us from in the chat function, we'd love to hear from you. So just the usual housekeeping bits and pieces. Those of you who've joined us before will know we have a couple of presentations generally that we run through, and then towards the end we will have some great Q&A discussion. We'll pop that into the chat feature. Your questions can go into the chat feature. Don't get too excited and put your chat questions too far up the front, because they can get a little bit lost. So perhaps, you know, hold that off until about the last 20 minutes of the session. And please always keep everything respectful. And just a quick reminder that the discussion is recorded and will be posted on our website after we've completed. So I would like to introduce to you again, many of you will be very familiar with Sam Mallor. Sam is Beyond Zero Emissions Engagement Lead and Project Lead in the Hunter Valley, and was the author of the Hunter case study in our Million Jobs Plan. And her current work is focused on making connections with local entrepreneurs and businesses that would fit perfectly into our model of a renewable energy industrial precinct. And we have two such entrepreneurs joining us today. So I'll just hand over straight to Sam, and she's going to introduce our guests as well as provide some sort of context around, you know, the manufacturing scene in the Hunter Valley these days and Newcastle.
Thank you so much, Nicole. Can you hear me okay?
Yep, great.
Okay, so last month at discussion group, I described the Renewable Energy Industrial Precinct project that we're working on here. And so this month we're just going to meet some of the people who are supporting us in that project, and both 3ME and Diffuse Energy are supporters of the Renewable Energy Industrial Precinct. And just I want everyone to start thinking about the Hunter a little bit differently. So now when you think about the Hunter, you probably think about the coal industry, you know, big, long coal trains, stockpiles of coal, dust, you know, coal loaders, ships coming in and out of the port of Newcastle. And that's true, that's still here. Last year, there were 158 million tonnes of coal, valued at $18.5 billion that left the port of Newcastle. And coal mining itself employs about 16,000 people across the Hunter. And then there's, you know, Liddell and Bayswater power stations, the massive transmission lines taking energy around the state, and energy employs another couple of thousand people. And then there's a lot of, you know, energy intensive industry, and for example, Tomago Aluminium employs just under 1,000 people on that one site alone. And then there's also the defence industry. The Williamtown Air Force Base employs 3,500 people. And there's a lot of different aircraft that are serviced there, but the F-35 jets probably are the most famous at the moment. So that's, you know, the traditional hunter that, you know, we know so well. But today we're going to be talking about a different aspect of the hunter, and that is the emerging clean tech sector here. And while defence and mining have been the backbone of the hunter economy till now, there's a cluster of SMEs that is built around those industries and the servicing and manufacturing for those industries. And they're really smart and innovative people and businesses. Both defence and mining have really high standards, really exacting standards. So this cluster of companies are used to delivering really high quality work. And these SMEs are driving diversification here. And today we're very fortunate to have Justin Bain, the CEO of 3ME, a company that works with both mining and defence. And he's going to talk to you about some really exciting things that are happening in his factory in Cardiff at Lake Macquarie. And another huge asset that we have here is the University of Newcastle. And again, being in the hunter, the university has really strong links with energy and defence and mining. The university is also ranked among the top research universities in the world, and they're really focused on commercialising their research. So today we're also going to hear from Dr. Joss Kesby from Diffuse Energy, and Diffuse Energy is an example of the commercialisation of university research. Diffuse is making really big strides for a young company. Diffuse has revolutionised small wind turbines, and last year was the recipient of some significant funding from ARENA. There are other manufacturers in the hunter that are pivoting to the zero emissions economy. One of the examples is Molycop, again, a company that traditionally supplies mining. And they are now one of Australia's largest buyers of renewable energy. They offer steel products with reduced embodied emissions. And another company is Amp Control that was developed doing electronics for the mines. And so they sort of grew up doing electronics for underground mines and such. But now they are delivering innovation to the renewable energy industry. I'm sitting here in the 1804 collaboration space where hunter clean tech startups are co-locating and collaborating. And around me, I'm working with coders from Switched In, which is a rapidly growing company whose software enables virtual power plants and microgrids. I was at a workshop the other day, a net zero hunter workshop, and one of the ideas that was flagged was to create the world's largest virtual power plant, and the innovative software to enable that is developed right here in this building. So I want you to think about the hunter in a different way. There is a clean tech revolution going on here, and we are like the Silicon Valley of clean tech, energy and advanced manufacturing. There's a bunch of incredibly smart and ambitious people working towards creating a zero emissions world. And the reason we're clustered here is because of the university and because of the legacy industries. But we are creating something completely different. It's a zero emissions energy, defence, mining and manufacturing hub. And it's by far the most exciting place to experience the energy transformation in Australia and maybe even the world. So I'll leave it there and I'll welcome Dr. Joss Kesby from Diffuse Energy.
Thank you very much, Sam. Thanks for the introduction, and I 100% wholeheartedly agree with you about the future of the Hunter region. It's you know, we do have a history in coal mining and in defence, and we are now sort of seeing the transition to diversify you know, our economy in the region. And I think Beyond Zero Emissions are doing a fantastic job of shouting that from the rooftops and sort of leading the way in making that happen. So I really applaud the work that you guys are doing. So let me just share my screen for a short little presentation. that I'll go through about what diffuse energy is doing and where we see the future. So basically, we do small wind energy systems with a real focus on the telecommunications industry as our first market. Our core technology is based on my PhD research from the university. We've still got really strong ties with the uni. We get to go and use all their test equipment and workshops and students and things as we need, which has saved us a lot of time and money and allows us to really bring to market a really, really strong, well-tested, well-designed product. Now, some of the applications of our systems, so we do really focus on the telco industry initially. We're only a small team, and it really makes sense for us to have, for a company in our position, to have one customer with 100 turbines rather than 100 customers with one turbine in terms of customer support and helping work through any challenges that some of our customers may face installing or sort of upgrading our systems. So you can see there a site up in Coffs Harbour on the right. You might be able to just see our little turbine right at the top there. That little turbine powers about 25% of that site, which is it's a pretty good outcome for such a small wind turbine. We've also, at the moment, so I think Sam alluded to, we had a project with ARENA that we got funded at the end of last year, and in this middle photo here, we've got that's our test setup that we've put together with solar panels, with batteries, with our wind turbine that helps us. So it mimics basically a telecommunications site, a typical site for our telecommunications customers would run. So it allows us to, it's just nearby, it's up in Lambs Valley in the Hunter region. And it allows us to go out there and swap things out and trial new things before we put them on a operating telecommunications site, where they can be a little bit more hesitant about mixing and matching and trialing new things. And then on the right there, that's another telecommunications site. We've got a customer that has solar panels and batteries in a containerized solution that they go and install out on remote sites where they have problems with power. So they're kind of like 3 setups that we sort of have out there at the moment. Now, what is our turbine? Basically, it's a small diffuser, what's known as a diffuser augmented wind turbine. My PhD research was all about optimizing that ring in conjunction with the blades, because when you get that correct, magic happens and you can really significantly improve the performance of the turbines. Our initial product is only 900 mil, 120 mils in diameter at its widest point. It weighs nearly 20 kgs with all the cabling and everything. We have the turbine will keep producing power up to about 70 or 80 kilometers an hour, depending on a few variables. And we currently have a survival wind speed rated of 150 k's an hour. We've designed everything to withstand 220 k's an hour, but we haven't been able to test that yet. But in terms of testing, we're going down to Monash University next month to go and really put it through its paces in a wind tunnel that's capable of doing 180 kilometres an hour. Really looking forward to that. It's going to be very exciting. See how how it all handles 180 k's an hour. It's going to be fun times. But saying that, we have had it out. We've got it out in the field in a variety of locations that have got up well over 100 k's an hour, up to nearly 110 k's an hour, and it's performed exactly as intended. Actually, it worked even better than expected. So yeah, it's a really rugged, reliable system we've designed and developed. Initially, we built the wind turbine. We're expecting to be able to use just off-the-shelf controllers. We tried a whole heap of them, and none of them were any good. So we had to go down the road of developing our own controller. And now we have, I can hand on heart say, we have hands down the world's best small wind turbine controller. It's taken us about 2 years, and I don't want to recount how much money to develop, but it's really worthwhile now, because we've got that system that we can stick out in the world anywhere, and we are really confident that it can perform exactly as it needs to, and can withstand whatever the environment's going to throw at it. And that's a really key part of our offering for the telco customers, is that these sites that we're putting our turbines on, they're out in the middle of nowhere, up on top of mountains. They're 4 or 5 hours from the nearest town. When they put something up these towers, they want them to stay there, and they don't want to have to think about it again. They just want to know that it's going to do what it needs to do year after year. And so that's been a really big part of what we do, making sure our system is really robust and really reliable. That's a really key part. So we can do 24 volts or 48 volts. Almost all of the telco systems use 48 volts, but occasionally every now and then they get a 24 volt system. Our turbine is rated to 220 watts at 40 k's an hour. But peak power output is about 650 watts. And for a good wind site, which has a 25 k an hour average wind speed, it'll do about 940 kilowatt hours a year. A big part of the project that we're doing with ARENA, which is all about basically getting telecommunications customers in partnership to go and put wind turbines on their sort of remote sites in conjunction with anemometer systems. And a big part of that project is also developing a remote monitoring system so that we can see what our turbines are doing anywhere in Australia in real time. And we've got the first iteration of that system out in the world, got a few improvements to make, but we're going to have a really strong commercial offering with the remote monitoring systems for our customers. And that's been another really big selling point of our system, is that we can tell them if the turbine's not doing what it needs to be doing. We can tell them if it's not performing correctly, so that they don't have to think about it. If there is an issue, we bring it to their attention. So we do have a few other applications that we've been pursuing and that we have turbines with. So we've got sort of remote or portable modular traffic management systems right there on the left. We've got a couple of sort of off-grid sites. And we do have a couple of sites around the mining area in Hunter Valley, and a couple are just about to go up around the Queensland area for mining to help power their communications. And every now and then, we do sell turbines to off-grid customers, like off-grid houses. So that's one down there on the right. He had his own tower already. I get a lot of emails every week, sometimes begging me to sell them a wind turbine, and by and large I don't at this stage, because for a wind turbine to make sense, it has to be in a good wind resource, and a lot of people think they have a good wind resource, but in reality they don't. If you're really struggling to keep the washing on the line, that's a good wind resource. Otherwise, maybe not. So our turbines, blows the competition away, so to speak. We up to twice the power output of the turbine of the same size as ours, and that's all around that diffuser, which is an aerodynamics shaped cylinder. In conjunction, optimizing that with the blades, that's where the magic really happens. There's a few big focuses of what we've been doing, but a key challenge that has plagued wind turbines in the past, plagued telecommunications companies trying to use wind turbines in the past, is that they're not easily integrated into their existing systems. But that's been another big focus of what we're doing with our control system. Developing our own, we've made it a really straightforward process to plug and play with existing solar panels and batteries and diesel generators. And we now can integrate really well into the main equipment suppliers to the telecommunications industry. And our product is 100% built in Australia, and about 80 to 90% of our components are made in Australia as well. But there's a couple of parts that we have to source from overseas. But effectively what we do, we get the various component manufacturers to build the blades, build the centre body, build the diffuser, gets sent to our workshop here in the Hunter Valley, and we assemble it and then send them out to our customers. And a big part of our offering is the way that we provide our turbines. So it's basically on a monthly subscription. We don't sell our turbines outright. And there's three key factors to that. There's no lock-in contract, so there's no upfront costs, and there's no maintenance to do for the customer. And that overcomes, so a lot of these telecommunications companies have really big problems with power for their remote sites. So they've been looking at alternate forms of power for a long time. They've almost all tried wind turbines in the past, and they haven't worked very well because they're either the turbines have fallen apart or they haven't integrated easily into their system. So a big part of what we say is, look, sign up to our subscription agreement. If it doesn't do what you need to do, you can send it back, and that's the end of it. But so far, you know, we've been operating had a commercial ready product since the middle of last year, and so far we've only had one turbine come back, and that was for other reasons. But it's a really good model that seems to really strike a chord with the telecommunications companies. So that's basically my presentation. I don't think I went too far over time. Hopefully not. Left some time for questions at the end, because I'm really keen to hear what if there are any questions about, you know, what we're doing and where we see the future going.
Yeah, thanks so much, Joss. I've actually just shot a note to everyone in the chat that it might be good to pop some questions in now, given that you and Justin are speaking on reasonably different topics. So yeah, please feel free to drop in a question now if you had something specific that you wanted to ask Josh on his amazing technology. I had a couple of things that came up as I was looking at your presentation. Really interesting. So you said, I think at one point it was 20 kilograms, the main sort of weight. What's the sort of the footprint that sits on? I was wondering if that's one of you know, the main advantages versus, say, a solar setup, which obviously has a quite broad span.
Yeah, so we don't say we're not competing with solar. Where we say is it's a really complementary technology with solar. So almost all of these sites that we are operating on already have solar and batteries, but because of where they are located up on top of mountains, there's not often physically enough space to put solar. So we have an alternate energy form, and we mount them directly on the tower. So we're not competing for space with solar either. And that makes a really big difference, because our first recommendation for a telecommunications company is always to get solar and to get batteries. And then we tie into that solar and battery system to really round out the renewable energy scenario for that site.
And we just got a question come through from Jeff Cummings. Can you tell us a bit about the ring around the propeller and how your turbine gets to such a high efficiency?
Yeah, so basically what the ring is called a diffuser, and effectively what it is, it's an aerofoil. It's basically like an aeroplane's wing, but just wrapped around in a cylinder. So if you can, so my PhD was all around optimizing the aerodynamics between the diffuser and the blades. If you get that right, and you can optimize those two things simultaneously, you can really get those efficiency gains. But it's really quite complex, because the performance of the diffuser impacts the blades, and the blades impact the diffuser. So it's like a simultaneous optimization, which can be a bit challenging. Yeah.
You can probably see these questions popping through. This sounds, you know, quite specific. Any opinion about vertical axis turbines, from Alan Strickland?
I do have some opinions.
Maybe you can explain to us layman what that means.
Okay, so our wind turbine is what's known as a horizontal axis wind turbine, which is like the big ones that you see that they spin around the horizontal axis, right? So a vertical axis spins around this way, around the vertical axis. So vertical axis wind turbines have their place. None of them are as efficient as a horizontal axis wind turbines, but they do have some benefits in being reasonably robust in some of them can be quite robust. Like we've talked to customers who've tried a whole range of different wind turbines, and the only ones that still go the distance are the vertical axis ones, because they get wind speed. This site gets wind speeds of 150 k's an hour quite regularly. But they haven't tried our wind turbine yet, but we're working on that.
Now, I'm hoping this one makes sense to you because I'm not sure exactly what they mean, but Alan Evans has asked, is there any equipment available so individuals can access their own wind resources in advance?
Yeah. So you can get fairly simple and relatively cheap weather monitoring stations that have anemometers. They're usually just sort of a cup and vane anemometer you can usually get them from Bunnings, they're a couple $100, I think. You could put that on your site where you think a wind turbine might go. So things to remember about wind turbines, the higher up you can get them, the better, generally. And they don't doesn't matter what sort of wind turbine you have, they don't like to be around obstruction. So they need to be higher, quite a lot higher than any surrounding buildings or trees. You need to have your prevailing wind pretty well clear of obstruction. So just sort of keep that in mind. But yeah, wind anemometers as part of sort of small weather stations are pretty readily available.
Sorry, and is that just to check where the best wind location is in your vicinity?
It's more around just seeing if your site does have a good wind resource or not.
Yeah, okay.
Yeah, so it's sort of like before you go and spend some money and putting wind turbines up and finding out, they're a lovely sort of garden ornament rather than actually producing any power, you go and do a wind study on your site. And we, as part of what we do, we provide, we do some desktop analysis for our customers to make sure where they're planning to put a wind turbine actually makes sense. Because sometimes it doesn't. By and large, for these remote sites, they're up on top of mountains, and generally they're 40 metres up the tower above at the top of the mountain. Usually that makes it a pretty good wind resource, but not always. So we do some analysis beforehand to make sure it's going to do what they need it to do.
Yeah, and you did mention the scaling and commercialisation of the operation. John Slade's got a great question around, potential to keep the jobs local when you do that scale up. Is that something you guys have looked into?
Oh yeah, absolutely. Like we want to keep everything on Australia, on Australian shores as much as possible. But unfortunately, there were components that we had to get overseas. Could not find anyone for love of money in Australia to make them. But we want to bring, where I see it, I'd love to bring that sort of capability back. And it's really around the electrical generators that we put in our turbines to actually produce electricity. Could not find anyone in Australia to do them for us because it's fairly need to have fairly particular, fairly rigid sort of specifications around that. Could not find anyone in Australia. Would love to be able to do that and bring it onshore though.
There you go. It's an opportunity for everyone. Get your ideas into Joss. And so Anne-Marie George has just said, thank you, that didn't know that these sorts of small wind turbines exist. And if you could tell us the main difference between, your product and then the large wind turbines that we would see.
Well, for a start, ours is about 100 times smaller. And so the large turbines, there's quite a difference between the really large turbines and really small turbines. I won't get too far into the technicalities of how it is, but basically it doesn't work just to take a large turbine and scale it down to the small size the aerodynamics don't scale that well. So typically for small wind turbines, the efficiencies have been pretty bad in terms of the power they can output. Large wind turbines, they can get up to sort of 40 to 50% efficient. Typically small wind turbines have been sort of 15, 20%. With our technology, we've been able to get to the efficiencies to getting close to what the large scale turbines are doing. So that's, so basically you'll never see our sort of technology in large wind farms. The three-bladed standard wind turbine that you sort of see everywhere in wind farms, it's a pretty good system.
Yeah, and there's a few questions that have come through around application, things like setting up on high-rise buildings, and also just wondering about the capacity. So you mentioned, I think, 940 kilowatt hours. Can you translate that into, is that a small building, couple of houses, or?
Yeah, not really. So for our current turbine, like for a good wind resource, for a site with a good wind resource, it will do a bit over 2 kilowatt hours a day. Although saying that, the other day we had a turbine up at Coffs Harbour, where the wind speeds we got up to 103 k's an hour we measured, and we pumped out nearly 10 kilowatt hours, which is basically half a household's sort of energy use per day. So that was a bit of a record for us. I always love, windy days like that. It's lovely to because we've got the remote monitoring system, so we can see what all of our turbines are doing in real time. It's pretty cool.
Wonder if you actually had any test models set up in Melbourne, Victoria last week. We had some serious winds.
But we are working with NBN Co. We'll have 5 down there hopefully the next month. Yeah.
Fantastic. All right, well, there's a couple more questions there, but we might just pause just to make sure that we've got time to cover everything, and we'll see if we've got a little bit more to throw at you at the end there, Joss. But thank you so much.
Thank you.
Really, really interesting product. And yes, thank you, Justin. I can see that you're getting ready. I'll hand over to you to run through your 3ME work.
Excellent. Just confirming you can hear me there?
Yes, sounds great.
Good stuff. Oh, great presentation from Josh there, and yeah, really exciting to actually be kicking off some early collaboration between Diffuse Energy and 3ME Technology, which I'd say has been a result through the Beyond Zero Emissions facilitation. So yeah, and also I guess off the back of that, a shout out to Beyond Zero Emissions for the great work they're doing in the Hunter through Sam Miller, and obviously more broadly across Australia. Really exciting initiative, and something that to be honest, probably 9 months ago we were buried in the workshop and weren't aware of what BZE is doing, and it's really exciting to see it accelerating ahead. So 3ME Technology, we're based here in Cardiff, Lake Macquarie. We've got about 35 people in the team, continuing to grow. It's obviously all about the people. I'm not a doctor like Josh or even an engineer, so we had to hire a lot of smarter people than me to help solve these problems in the technology focus that where we're focused. Excited that we have quite a diverse workforce in that we've got defence veterans, 30% of our workforce out of defence. As well as people who have transitioned out of the underground mining industry with I guess the high levels of safety and compliance, combined with a lot of next gen technologists out of Newcastle University around Australia, and apprentices as well involved in STEM. So what does 3ME do? We do clean tech for tough industries, but very much focused on battery systems. Our core products and services include lithium-ion battery systems. I'll dive into that separately. And then in order to get our battery systems to market in these mobile applications, we've pulled together other, I guess, non-proprietary equipment and obviously software to work with vehicle OEM partners to electrify their offerings. So our core markets being mining, military, and marine, of which we've been targeting them in that order, and pulling together systems and I guess solving problems for vehicle OEMs to support their transition towards more efficient, sustainable solutions. But keen to dive into our proprietary product, which is BladeVolt. So BladeVolt is we consider a state-of-the-art battery management system. We're agnostic to the cells that we integrate. We use large format lithium polymer pouch cells. But obviously there's a lot of exciting developments happening with cell chemistry, and we're able to, we've got the chemistries that we like, which we're certified to intrinsic safety, but we're able to agnostically integrate a range of different chemistries as they continue to further develop. There's obviously a lot happening in the battery space in the mobile applications, and a lot of those have grown out of the passenger market. So what we saw is solutions for passenger cars growing into buses, then being scaled into construction equipment, and then into the mining industry. We've started at the other end and said that heavy industry or heavy duty applications, high reliability applications with high levels of safety and compliance need a solution that's purpose designed for that. We've been funded by the mining industry to develop a solution for them, which has subsequently found strong relevance in the defence sector as well. So BladeVault, it's Australian intellectual property. We have a provisional patent in place for the hardware. All the software is done in-house. Talking about local Australian manufacturing, we've applied for the Modern Manufacturing Initiative, and we're continuing to, onshore and in-house and collaborate with Australian companies to support our supply chain resilience, obviously local employment, and also to meet the defence sovereign capability requirements. So BladeVault gives us the ability to scale battery solutions onto large tonnage platforms, and I'll show you some photos of some of the projects we've worked on, with the key function being whilst maintaining safety at the cell level. So we've taken what is traditionally a battery management system sitting over a range of cells, and we're doing that down at the individual cell level. And the key reason for that is, the applications that we're focused in underground mining, in subsurface applications. The risk of, we just cannot have the risk of a fire, and we need to be able to neutralise that risk through additional monitoring and maintenance, and be able to isolate cells and a pack in the event that a battery is trending towards an unsafe event. The systems are smart and networked, and similar to Josh with their monitoring, we have a battery systems operations centre, and that's a key point of difference in that we're able to provide a fully supported battery system, which are networked through the vehicles, and we're able to dive down to the cell level and look at charging characteristics, temperatures, cycle life, and this is enabling us to transition towards where we'd like to be, which is batteries as a service, and to be able to actually lease the batteries out and manage them throughout their life cycle, and then be able to effectively repurpose them from mobile applications into static storage applications. So obviously, when a battery's finished its first life in a mobile application, in the automotive sector, 80% depth of discharge is considered, the end of life for the first one, and then you've still got a huge amount of capacity that can be redeployed and reused. And then in terms of end of life, due to the modular ability of the battery, we're able to take cells off, process cells through recycling, with the lithium-ion value chain stepping up in that, and then with our copper core printed circuit board. So an example of some of the key projects, I figured pictures would be most descriptive. So here is a Tritip. It's a 20-tonne fully battery-powered loader used as an integrated tool carrier in underground mines. We have collaborated with a company called Batmobile Equipment, BME, which is a sister company of Australian Mining Equipment, again here in the Hunter, and obviously another Australian company. The mining industry and underground is, I believe, is really well suited for electrification, in that the vehicles spend half the time driving down, obviously where you can regenerate energy. In terms of charging infrastructure, there's already electrical infrastructure underground with these big things called jumbos, which are effectively big Tesla superchargers that are already laid out. And then also from an energy efficiency or cutting down the energy usage, underground ventilation of mines is hugely energy consuming, and to be able to take away the diesel and take away the heat with the battery electric piece of equipment, there are those second and third order effects and benefits, including, of course, work health safety, removing workers from that proximity to the diesel particulate matter and heat and dust and noise that they work around currently. We've also worked with a company called Safescape on a battery electric utility vehicle, again for underground, primarily for underground applications as well. It's basically a Toyota Land Cruiser on steroids, higher payload, corrosion protected, fully battery electric, 1000-volt charging, and a range of other capabilities. So both excitingly, both the Tritip, the previous picture, and the Vortana projects with our partners that have progressed from prototype into beta phase rollouts and have production contracts. Yeah, this one always forgets people squinting, but we're also excited to be working with AMSERO, a Sydney-based Australian company working on electric vertical takeoff landing craft, and we've supported them over the last 2.5 years with prototype battery systems and some other tech integration support. And yeah, they've been pretty quiet, but I expect them to be some more information coming out about them over the coming months and years. But a really exciting company. And then defence industry. So I guess with COVID and some of the geopolitics, we've seen a real acceleration towards Australian industry content and sovereign capabilities. And I guess with our focus on high reliability, clean tech with high levels of functional safety, we've found a really neat position in defence as well. And obviously with people like myself with the defence background, understanding the operational requirements, we've been able to transition the technology. Obviously underground mining is a perfect test bed for equipment as well. So I got one photo blurred out on there, but the core projects we're working on are auxiliary power solutions, so lead acid battery replacements with more energy dense, smarter packs, which are part of land programs. We're also working on full electric light vehicles and hybrid systems. And an interesting one we're involved in is a program called C4 Edge, of which we've taken our blade vault battery system and made what we've called a mini blade, now Saver Vault, and we're actually developing a next generation soldier battery system using, I guess, a smaller version of what's come out of the mining industry. So that's it from me on a quick barrage of information, but yeah, quite excited to answer some questions about what we're doing, and I think that's probably the more important part of the group.
Thanks so much, Justin. Very interesting. I have a question. I wasn't sure about the size of the batteries. In some of the first slides that you had, they looked quite large, but then you showed the application of the helicopter. So there obviously are different weights and sizes of the batteries that you're creating. What was sitting in that particular system?
Yeah, so within the, be careful what I say for AMSERO, but each of our, I mean, for the mining clients, it's the same core building blocks, so same core blades that we build, whatever kilowatt hour requirement in the dimensional space that we have available. Whereas projects like AMSERO are more custom, we've had to meet a specific requirement for them. And then, but yeah, certainly for mining, it's behind me here is I guess a test bed where we've got an individual blade showing that level of size, and then those blades we can build, whether it's dual row, triple row, triple back, single high. We use that as a building block to meet the customer's requirements. And the soldier battery is a bit smaller. Obviously, soldiers like to carry things that are as lightweight as possible, and so that's our next generation soldier battery, which so you can't see the weight there, but is a hell of a lot lighter and more energy dense than the solutions currently being used.
Thank you. I've just got a question from Alan Strickland. Could you compare the round trip efficiency of the batteries versus a hydrogen fuel cell?
So we are involved in some, I guess, future hydrogen pieces. I wouldn't be able to quote a side-by-side example, but from, I guess, where we're focused in underground, we see that being full battery electric solutions. And then I guess my simple layman's answer on that is that I feel from a hydrogen perspective, bigger is better, and that what's rolling out in the haul truck scenarios is a place to play for hydrogen, and that and when we're seeing some collaboration and developments in that space. But yeah, I think from a smaller vehicles, when you're getting that the energy transition and chemistry transition, we're seeing that the efficiency is not there, and it's not required in those scenarios where you can get the charge discharge duty cycles.
Yeah. Just going back to the fact that you obviously have strong ties with the military, and I believe you said funding. What were their sort of drivers with investing in this sort of electric technology? Was it health as the main thing? You mentioned, obviously getting the diesel out of those underground applications. Yeah,
so I'd say for coming back, I'll get back to defence in one sec, but the key drivers for mining, particularly in underground, have been work health safety, and then now realising the actual productivity benefits, and also integration with autonomous solutions, being more digital to digital, which has accelerated through COVID. In terms of surface mining, we are seeing obviously a lot of shareholder pressure for decarbonisation, and that social licence to operate being a key risk to mining operations, and obviously aggressive targets are now being set. And solutions are, a range of solutions. It's not just batteries, it may be hydrogen, it's wind, it's solar, it's more efficient drivetrains. It's a whole range of solutions. But in defence, key benefits of electrification in defence, really come down to survivability and stealth. Being able to and obviously more energy demands both on soldiers and mobile applications. So the solutions that we're working on for I guess more traditional armoured vehicles are hybrid systems, but you're able to get a silent watch capability where if the vehicle is in an overwatch, it can be running off just batteries, still powering all its equipment, and it's it's effectively silent. And you can use a silent approach as well. And then what that means also is a lot of heat. A lot less heat, which is obviously good from a sense of survivability perspective, and also not having one centralised engine. So whether it's in-wheel hub motors or dual motors, being able to support survivability and in-field reliability. Electric systems, far less maintenance, which is another big benefit in the mining industry, which has supported lower total costs of ownership. And a lot of these defence platforms, they're not used like mining vehicles every day. The usability is actually very low until obviously they're in situations where they get used a lot.
Thank you. Sorry, I got my military and my mining mixed up there, but thank you for answering it on both fronts. You mentioned, so I've got a question from Richard Jansen. You mentioned marine applications and what projects do you currently have in marine? And I'm thinking this is a local reference, but Stockton Ferry, ? Electric?
Yeah, we'd love to electrify the Stockton Ferry. That's on the list. I think there's been a few assessments of that, but that would certainly be a good target. Yeah, but for us, it's both auxiliary power storage. We are supplying the same batteries that we've developed for land systems into defence marine systems for auxiliary power. And then we've also got some progression in the subsurface space in both defence and also remote operating vehicle spaces as well.
From Michael Faulkner, would the blade system allow for charging outside the battery, i.e. having a spare external charged battery blade and a quick changeover?
So it is, you could. The batteries are designed to be maintenance free and charged as a whole system. But one of the key benefits that's come from the modularity is that in the event throughout its life cycle you do have an issue with an individual cell, the system can be isolated, a blade can be taken out, a new blade can be placed in, and because of the management system being at the cell level, it can then balance back in with the pack and be quickly redeployed, which is not the case with other systems that are either all cabled up or ultrasonically welded or don't have the management system at the cell level. And that's I guess a key feature that's come out of both our ability to meet the safety requirements and also the feedback we got from early adopters in North America with battery electric equipment and what was important for them.
Yeah, it sounds like a really good advantage. Okay, another one from Richard Bentley. Moving public transport to electric systems seems to be a big opportunity in Australia, and do you have any prospects for providing solutions in that sector?
Yeah, so we do get engaged on an almost daily basis, which is exciting because it really shows that the electrification, across multiple sectors is really accelerating, very quickly. We are a small company trying to scale as fast as we can. So, we're really going after what we consider harder targets that we know that we can play to win in. But certainly, if the volume's there and the margins are there, we would I'd consider distract ourselves in things that are outside of our core markets, being mining, military, marine. And I guess we're seeing that now that we're scaling our production, there's opportunities for us to also play more in that component supply space where, someone might have already electrified solution and they want from us, just a battery or just a widget, as opposed to the full system integration that we've done previously, which can be time consuming and draw quite a bit of capacity. So in short, yes, we are involved and have done some feasibility on busing projects, but yeah, trying to remain focused on core business. Yeah.
And what happens to the batteries when they've finished their life cycle in the vehicles?
Yeah, so we're actually excited to have been putting in place a static storage. So we were able to win a tender with another partner to deploy Blade Vault, which is the same solution we're putting in a mining vehicle already into a static storage application for a backup power supply. I'm not sure if I've got clearance to mention which customer. And with that, that's really great because it's demonstrating that we can already establish this market for static storage whilst deploying into the mobile application. So after the mobile application, we see great opportunity to redeploy these batteries that can have a long life as either uninterrupted power supplies or static storage, ideally within our core markets, but do have a lot of family and friends that keep asking for home storage as well.
And just actually going on, one that I missed a little bit earlier, I'm not sure how much your area of the organisation looks at this, but do you have much understanding of the management of the environmental impacts of the lithium mining? It obviously comes with the battery creation. In
terms of which part of it from a broader mining sustainability perspective, or?
I haven't got any more detail. That question was from Kirsten Duncan. If you want to jump in, Kirsten.
Well, I think that the key point is that, the industries we're playing in are those industries that, whether it's mining or defence, can be quite often the ones that have the most focus from people who are most passionate about sustainability. And I guess, myself certainly very passionate about sustainability, and I think that the mining industry, has a core role to play in this energy transition. We see solar panels, wind turbines, all the grid works. So all the core components coming out of the mining industry, and so actually that should be mined in the most sustainable means possible. And obviously different mining projects have different levels of sustainability, but the mining industry is clearly coming under more scrutiny with the social licence to operate, and we are seeing an accelerated focus from mining companies, and it doesn't talk just to environmental, but obviously even people, the ability to attract the next generations into the workforce who are more conscious about sustainability.
Yeah, and probably following on, I guess, sticking with lithium, I think you did mention really early on that there was some work playing around with the different chemistries involved in the cell creation. So someone's just, Douglas Hughes has just asked, are you investigating any other cell chemistry apart from lithium ion?
Yeah, so I think lithium ion, I think for it to become commercially, there's a lot of great developments in new chemistries. I think, solid state is the next kind of leap where there's no electrolyte, and then from a safety perspective, that's being pushed as the next leap in safety and energy density. But I would caveat that with it's really taken approximately 25 years to hit this cross section where you've got tested chemistries which are available at scale and are commercially viable to deploy. So we get contacted, and we've got a lot of engagement with others, growing new cell developments. But it can be quite hard to get them to send you a sample pack, or to have see a production facility. So I think it's a matter of delivering with the current capability, and then keeping your eye on the next developments and remaining engaged and transitioning once you've got all that data and it's commercially viable. But yes, the chemistries, most of the ones we're playing with at the moment are lithium based. So the NMCs, the LTOs, the NCAs, the lithium, the LPOs, LiFePOs, and then we see that transition to the solid state being the next step. Yeah,
fantastic. I know there's lots of questions still for both of you probably, but we're getting very close to the end, so I might just quickly pause there. I might see if Sam would like to just have some closing words or any final questions for our two wonderful guests. It's been some great discussion today.
Yeah, so thank you everyone for coming to discussion group today, and with Joss and Justin, I guess you are seeing some of the exciting things that are happening here in the Hunter and the new economy that is breaking out here. So thank you very much, everyone.
Thanks, Sam. So we might just pause there. Well, there was actually one last question that came through a couple of times. I might go quickly back to Justin, just how much competition you have in, and how big is the market in the batteries that you're creating? Because it does seem like you're probably not the only player.
Yeah, so I mean, competition-wise, we're not competing with the multinational who have kind of standard formats. We're really going after the markets that require that safety certification, risk assessment, implementation, and I guess closer into partnership with the vehicle OEM. And from a market size, we're very focused at the moment with our partners on the retrofit market. So actually taking existing diesel equipment, diesel out, battery in, concurrent to working on new developments. So the market to me is really every mining and defence vehicle, whether it's already in existence or is coming to market. And we see that we believe we can target a good percentage of that. And then I think someone asked that. I know something popped up around mining staff from mining industries. Just answering that one, I think it says how much deliberate support is from the government for retraining out of mining. We haven't had any deliberate support with that, but we have received. I guess I'm grateful for the government funding we have received through both METS Ignited and the Accelerating Commercialisation Program, which has enabled us to poach people from the mining industry. So.
All right, thank you so much. Thanks to both Joss Kesby and Justin Bain for joining us today. We really, really appreciate your time. And thank you to everyone for joining us and your wonderful questions. Participation has been fantastic. If you would like to see more of this sort of work, please always remember you can go to the Beyond Zero Emissions website, pze.org.au, and show us your support through our donations page. And we will finish up there. We'll make sure that we get all of the resources, the presentations to you. Afterwards, we will pop a recording onto the events page. Everything you need will be there, or you can always reach out to me. And we'll bring our discussion for this month to a close. Thank you so much, everyone, for joining, and we'll see you next month.